Yes, sir. All right. So you want to do a number here? I'll put it in. Yes, sir. Okay. All right. Let me know you ready? Yeah. Adjusted. Hey, David, you know how to zap the lights?
I got it.
Okay, Trevor's gonna do it. All right. Thank you, Trevor. Okay, so 7:30 and we are going to get started. Welcome to the October meeting of the Johnson Space Center Astronomical Society. And this picture, I didn't change this month, but that's another one of Stan's beautiful pictures that we saw last month, but we'll update them soon. So there's Stan right there. He's the guy that did that one. Good job, Stan. Here's our agenda for tonight. We're gonna have all kinds of things going on here. It's gonna be a great meeting. Take a look at that agenda. So if you would like to get on our email distribution, we have two email distributions. One of them is for meetings only, which is the top one there. That's Ron back there. And the bottom one is David, Starhopper 457. That's for everything. And you can either take a picture of those, write those email addresses down, or there's little tear-off tabs up there by where David is standing. And you can take that home, send an email, and you can get on our distribution. Okay, so before we get started here, I'd like to welcome anyone who this is your first time here. If your first time here, you can raise your hand, tell us your name, how you found out about the JSC AS, and what your interest is in astronomy. Put your hand down. Anybody willing to admit that this is your, right here?
Hi, my name is Dennis. First time here, bringing a little guy to get him educated and
He's hiding.
he likes them. And I think we found out with, I think it was Eventbrite, announced on Eventbrite, or Meetup somewhere.
Great.
That's how we found it.
Excellent. We're glad that you're here. And we've heard a lot of people find out about us on Meetup. So that's great. Tell us your name one more time.
Dennis.
Dennis?
Dennis.
Dennis, got it.
Henry.
And Henry, Dennis and Henry. Very good. Anybody else? First time here? Everybody else is kind of familiar. All right. There's somebody with Reed that doesn't look familiar. Is that his first time here? No? Yeah.
Oh, I've been here before.
Okay, sorry. All right, we'll move on. Okay, so note to speaker. There's our speaker up there, Leonard. When you get up here, just use the mouse pointer, please. And I told you about the microphones where they are, so you got that all understanding there. Okay, so Leonard Ferguson is going to be our main speaker tonight with the Europa Clipper mission presentation. And before Leonard comes up here, I'd like to tell you a little bit about him. Leonard Ferguson is an active amateur astronomer with a particular interest in our sun and variable stars. He's a longtime volunteer at the Houston Museum of Natural Sciences George Observatory, conducting classroom presentations during public star parties and assisting with the operation of the dome telescopes. He is active in Fort Bend Astronomy Club, assisting with educational programs and helping to support and organize club meetings and activities, and writes stargazing articles for several publications. So with that, join me in welcoming Leonard Ferguson.
All right, how's everybody? Okay, we're going to do talk a little bit about Europa Clipper mission. So this is going to be kind of an overview. We're not going to get really too deep into the instruments or the science or anything. It's kind of a mission overview and a little bit about what they hope to accomplish. So we'll go through this. It's going to be a little bit different. We'll do questions as we go along if y'all have any. We're not going to do a Q&A at the end. So little bit different, but I'll go ahead and give you a spoiler. There's a nice poem at the end that goes along with the spacecraft. So that's going to be the last slide. So, okay, so with that, we'll move on to skip the title slide here. Enter, okay.
Yeah.
All right, we should have been on this slide. Okay, so the big question is, why are we going to go to Europa? And I'm going to come back to that question. And first, I'd like to talk a little bit about decadal surveys. If you're unfamiliar with these are kind of studies that NASA commissions, as the name implies, about every 10 years. And they do them along all the major scientific disciplines. So these are not all of them, but astrophysics, planetary, we're going to do planetary, of course. So the planetary they do on the three. So there's one done 2003-13. This is a one from 2023, 700 pages plus. So light reading. But what these do is they convene panels. This goes to the National Science Foundation. They convene panels of scientists and engineers, leaders in the field, and they develop a plan that they recommend to NASA as this is the direction we need to take our science for the next 10 years. And that's what goes into the report. So a lot of them are done along the primary mission programs that NASA does for planetary exploration. So discovery program, that these are smaller, focused, faster development time, and lower budget missions. So missions like this would be like Mars Insight, Mars Odyssey, the Psyche mission that just launched about a year ago, Lucy, those missions out to asteroids. Those are kind of examples of discovery class missions. So again, smaller missions, kind of a little more focused science, and faster development time, lower budget. So we get a lot of missions out there. So New Frontiers are a little bit more of a science-oriented, high-value science mission. So there's only 4 of those right now. So that was New Horizons that flew past Pluto, coming up on 10 years next summer. And OSIRIS-REx that retrieved the sample from Bennu, brought that back last September. And then Juno that's currently in orbit around Jupiter. There is a 4th New Frontiers program in development. It's called Dragonfly. That is scheduled to launch, I think, either 2027 or 2028. And that will be a rotorcraft mission to Saturn's moon, Titan. So that is New Frontiers. And then the flagship missions are the large and complex missions. So that's Europa Clipper falls into that category, along with the Mars rovers and that type of thing. So, but these are the missions that are designed to kind of answer the big questions, such as habitability on Europa. So now in the 2013 decadal survey, I'm just putting this is just the title screen of this conceptual study they did. This was a 39-page study that was included in there. And this was the recommendation for an orbiter to Europa. So I stuck this in here. But what I wanted to point out, if you look at the date there on the lower right, that's 2010 this was done. And so now we're up to almost 2025. So, we've got 15 years in development to launch. Then we've got a 6-year trip out to Jupiter, and then about a 5 to 6 year mission to complete the primary mission. So, before you know it, you're 25 years into one of these big missions. So it's kind of, when you see these astronomers and scientists interviewed on these programs, and they say they've spent their entire career on one of these missions, it's pretty easy to do. So just to kind of point that out a little bit. So, okay, so here we are back to Europa, and I think this is a fairly popular image. I hope everybody's somewhat familiar with it. But the thing we want to do and go to Europa is to explore and see if the primary mission of this mission, or the primary focus of this mission, is to see if conditions exist that might be habitable on Europa. So we have a lot of formations here, you see these long fractures in the surface. So this is a planet-wide or a moon-wide ice cap here that may be somewhere between 6 and 10 miles thick. So you see these long fractures here, which have as that surface has cracked and reformed. There's areas over here which they call chaos terrain, and I've got a little bit some other slides that kind of demonstrate that. But that's kind of where maybe the ice has come up and kind of crumbled and then reformed at the surface and refrozen. And then we have some spots over here that are kind of hard to see if we had a close up. Those are called lenticulae. But the one thing, if you look, what's the one thing that's missing, or mostly missing? That's craters. So Europa, the average age of the surface across Europa is about 50 million years. So that's, in human terms, obviously that's a long time, but in planetary time, that's very young. So Europa has one of the youngest surfaces in our solar system. So when Galileo pointed his telescope at Jupiter in January of 1610, this is what he saw. So this is an actual copy of one of the sketches out of one of his journals. So he saw these objects. He initially named them the Medicean stars in honor of the Grand Duke of Tuscany. So he looked at them the first night and he saw this. This wasn't the first night, but he made a sketch, and then maybe the next night or a couple nights he looked at them again. Of course, he's moved pretty quick, so they're all in different positions. And then a couple of nights later, same thing. So these are moving. So it didn't take him long to figure out that these objects were actually in orbit around Jupiter. So that kind of went along with his. He was in favor of the Copernican theory of heliocentrism. But at the time, primary thinking in the scientific community is everything that the Earth was the center of the universe. So this didn't go over well. And of course, there's a lot of controversy there. So I'll leave that to y'all to look up on your own. So, but anyway, so 350 years, telescopes are getting better. Telescopes are getting bigger. Optics are getting better. But we kind of stayed with this image here for most of that time, until 1979, when the Voyager mission flew past and actually got an image of Io and a volcano erupting. It was the first image of a volcano erupting that was not on Earth. So we had that, and then in the late 1990s, we sent Galileo spacecraft out there, another flagship mission, and now we got close-ups of all of these moons moving out. And we kind of started to realize that this is almost kind of make up their own miniature solar system out there. You've got Io here with all its volcanism, Europa with its ice cap and ocean, Ganymede and Callisto. So these, the inner three moons, Ganymede, Europa, and Callisto, are locked in what they call a tidal resonance, a 4-2-1 resonance. So for every one orbit of Ganymede, Europa makes 2 complete orbits, and your Io makes 4. So every orbit of Ganymede, they all come along and they line up. So the gravitational influence among those moons lined up with Jupiter causes what they call tidal flexing. And I've got an animation there, but it's basically flexing the interior of these bodies, and which generates heat. There is some evidence between a resonance between Callisto and Ganymede that's like a 12-5, but it's not exact. So that's subject to study. But the main resonance here is between the inner three. So in addition to this, all these 4 moons are also tidally locked, just like the moon is with Earth. So the same side of all these moons faces Jupiter all the time. And that's the case with most of the moons in our solar system. So over time, they have become locked into this position. So close up here of some of the fractures along the surface here. You can see where this has occurred repeatedly and refrozen. You can kind of see how they're layered. This has happened one on top of the other. So as the surface fractures and reforms, you're getting this kind of. Yes, sir.
So
that right-hand picture, what was that taken with?
These are, these are all from Galileo.
Okay, so the right one's from Galileo?
I believe so.
Okay, thanks.
Okay, so here's the chaos terrain. So this is where maybe like you see these ice fields on Earth where icebergs, it's all just jumbled up, and it'll refreeze in place like that. So here's one of the craters here. This is called Quill. This is that one towards the lower bottom there. So, and you can kind of see maybe some of the same mechanics, like we look at craters on the moon and you see all those bright rays going out. So even though this is ice, we're probably looking at some of the same mechanics in the formation of these crater rays. And then here's some of the close-ups of the lenticulae. So they think these are probably areas where maybe material from the ocean underneath has worked its way up to the surface, and it's leaving these marks here. So underneath this ice cap, which the currently is like 6 to 10 miles thick or so, and then underneath that is a global ocean. And the measurements from the magnetometer on Galileo indicate that this ocean could be as much as 100 miles deep, somewhere between 60 and 100 miles deep. So you have a metallic core and a rocky mantle, kind of some of the similar things we have on Earth, and then a global ocean. So the way they determine this is the magnetometer measurements from Galileo. Europa does not have its own magnetic field like Earth does. So the magnetic field is being induced. And so as Europa moves through Jupiter's radiation field, that's all charged particles. And from looking at that and looking at the composition of the ocean, or looking at the magnetic field, they can determine the composition of the ocean. So this has to be a saltwater ocean, not quite as salty as the salinity levels, not as much as it is on Earth, but it has to be a saltwater ocean in order for the conductivity to be high enough to generate this magnetic field. So that's how they made these determinations. So if you look at just composition here, Europa's probably got twice the water that Earth has over the entire planet. So that's a lot of water. So we've got, if we look at this slide here, so we've got, of course, present life, known life here on Earth. Mars, we have rovers. We sent Curiosity to look on Mars to look for evidence of past habitability, and now Perseverance is looking for actually signs of past life. Yes, sir.
On the previous slide, I got me curious. Can that ice on the outside articulate and move independent of the rocky core?
Yes, I've got a slide on that in just a minute. I think that'll help when we get there. So just to reiterate, Europa Clipper is a habitability search, not a life search. To do a life search, and unless they see something on the surface that's just plainly obvious current life, they would have to. But to really do a search for current life, they would have to send probably a lander or something to land on the surface, actually touch the surface and be able to sample some of the material. So just keep in mind, this is a habitability search and not a direct search for life. So here's an animation of the tidal flexing. Of course, this is greatly exaggerated, but as the moons move around Jupiter and interact with each other, gravitational forces are pushing and pulling on the interior of these bodies, and that generates heat from internal heat. So here's the slide, David, you were asking about. So this is what they think probably have a frozen, stiff cap of ice that's exposed to space, and then underneath it there's going to be a layer of still frozen solid, but this is kind of a little bit more pliant ice that can move around underneath the surface, and it's interacting with the top of that ocean. And then so if you look here on the this image right here is where possibly some of those areas are coming up and creating this chaos terrain. And then, possibly over here, either one of these where the lenticula is probably a narrow passage up through that ice where this material can just get out in a small spot.
When you said earlier the surface was 6 to 10 miles, is that entire?
That's the whole, yes, sir. That's the whole up top to the bottom to the top of the ocean. Okay, so just a simplified graphic here. So we've got all, this is why we're going to Europa to look. We've got all the components for life, we believe here. We've got plenty of water. We've got essential elements. So another important thing to remember here is the ocean on Europa is sitting right on top of the mantle and interacting directly. So there's chemistry that happens there that with those interactions. So there's and then we've got that energy. We've got heat energy coming up from the core, from the tidal friction. Also have energy coming from space from Jupiter as Europa moves through the radiation belts. You have energy coming and possibly penetrating this ice cap. So that'll be one of the main things that the mission looks at as well. And we've got stability. Yes, sir.
Yeah, so do we know about what the temperature of the liquid part is?
I don't think so.
We don't really know what it is.
You know, we'll have to go look at it. So we've got stability as well. So time. So that tidal resonance between the inner three moons that I talked about, they think that resonance set up not long after the Jupiter system formed. So it's been sitting there stewing for about 4 billion years. So if anything was going to evolve from there, it's had plenty of time. So we've got all the components, and we may find something like this.
So right now we're at a depth of 3,275 meters, looking at an incredible black smoker hydrothermal vent chimney. That black fluid coming out there is likely between 300 and 400 degrees centigrade. These ecosystems are literally islands or oases amongst what is, I mean, it's really cliche, and the deep sea is definitely not a desert, but relatively islands of abundant fauna, islands of life in what is usually desert-like deep sea floor. Oh, this is so cool! What, 27 meters high? 30 meters high.
Okay, so it's, down in the deep ocean, was it 10 or 11,000 feet deep? And the temperatures around that hydrothermal vent are let's say 300 or 400, that's 600-800 degrees Fahrenheit. Conditions that we would never expect life on the surface. But we go down to the deep ocean and we find entire ecosystems that have evolved down there independent of the sun. So this could be going on Europa. Life as we know it could be there right now. So I think we've covered most of these here. We've got the question.
Is it suspect molten rock in?
Probably down underneath, similar possibly to Earth, down in the mantle, and so the heat from the subsurface is probably keeping enough energy to keep that ocean in a liquid form.
Is there any indication for the presence of nitrogen or those kind of elements which are necessary for life?
The spacecraft will have some instruments on there to measure that. I think there's indications they got from Galileo, but no direct measurements. So actually the next slide, we've already covered this, so I'm going to skip to the next slide. So let's see, which one is it? The mass spec down there at the bottom. So they'll actually and actually the dust analyzer. So I'm going to go over the orbits in a minute, but as the spacecraft makes a close pass by Europa, they will actually take samples with those two, with the mass specs and the SUDA, and actually they'll have analyzers on board to actually measure those compositions. So yeah, well, so we're going with the in situ instruments down here at the bottom. We've got the magnetometer and the pins there, which is we'll measure the plasma environment around Europa. And then that gravity radio science, that's an experiment that's going on. That's not one of the main instruments. So then as the spacecraft makes its orbit, we've got the UV camera there, and then what they call the ICE camera there is the second one. So that's a wide angle camera. The MICE instrument is infrared, and then the thermal imager right there, the e-themis, they think that may actually penetrate the ice along with the radar, and they may actually be able to detect the top of the ocean. So at that point, we'll get a direct measurement of exactly how thick that ice cap is. So these are the 9 primary instruments that the spacecraft. So we'll be taking images basically from orbit. So one thing I didn't mention, so the spacecraft can't orbit Europa directly because Europa is directly in one of Jupiter's radiation belts. So what the team decided to do is kind of similar to Juno. They put it in a very long elliptical orbit around Jupiter and then had to make a close pass around Europa every so often. I've got an animation of that in a minute. So here's just a diagram of solar panels. So we've got the radar is on 2 separate frequencies. There's the VHF and the HF here are the longer instruments. So that's a 2 frequency radar instrument. Most of the cameras and all are here on the bottom, and then the magnetometer is here on this long boom here to get that. And we've got to get that magnetometer as far away from the spacecraft as we can, so that the material, anything going on with the spacecraft, doesn't interfere with the measurements. And then we've got 24 engines on board for course correction. So here's an animation here of Jupiter's radiation belts, and then you can see on the left there is Europa orbits right in those belts. So we've got to keep the spacecraft out of that as much as they can. So by doing long elliptical orbits, there will be, as it passes in, there will be a brief spike in radiation. Of course, all this is cumulative to the spacecraft and the electronics. So it'll get a little bit, and then cumulative over the course of the mission, which is about 3.5 years, so about 50 orbits is the goal to keep the spacecraft going. So by doing those orbits like that, we'll build up a network here over time and be able to cover the entire surface of Europa. So this is going to take, now this is, you see that on the left, 50 orbits over 3.5 years. So once they arrive, when the spacecraft arrives at Jupiter, it's going to take about 1.5 years of course corrections to get it into its science orbit before they can start these measurements. So here's just a couple shots of the, give you some idea of the scale of the instruments here. That ECM, that's one of the antennas, and then the plasma instrument there. I've got some humans in here so you can get an idea of the scale. So the ICE camera there, and e-themis, and then on the far right there are the radar instruments. And then here's just a shot of the assembled spacecraft here. So it's a large spacecraft. They actually had to so the instruments here, we had the dust analyzer there and the mass spectrometer there and that, if you kind of look over here, this is that's one of the telescopes. That's one of the telescopes for the ultraviolet camera. So it was these solar panels are so big, they actually had to ship them. They couldn't assemble this at JPL as a whole, so it wouldn't go in the vacuum chamber. So they built the spacecraft, did all the vacuum testing, and then shipped the solar panels to Florida separately and assembled them to the spacecraft there. So here's the spacecraft in the vacuum chamber, and then after final assembly, right there on the right, all put together. So that the communication disc there is about 10 feet across. All right, so we got to do a graph, right, with the sizes here. So we'll start with SLS, Statue of Liberty, 6 school buses, and a SpaceX Falcon Heavy. So this is our launch vehicle here. We'll launch off of Launch Complex 39A when we'll cover that in a second here. And then here's the size of the Europa Clipper. It's about 100 feet across, and something a little more might be familiar with is the size of a basketball court. So originally the launch date was yesterday at about 11:30 our time. I think the hurricane went pretty much right over the space center here. So I think Sunday they secured all the spacecraft in SpaceX's hangar right there. So right now they're assessing the condition of everything, and then they'll set a new launch date. So launch window opened up yesterday. Like I said, about this is I think technically 11:31 our time. It goes through November 6th. So we have about 3 weeks during this launch window to launch. So we'll launch off of 39A right here, and board A. So once we launch, it's about a 6-year trip out to Jupiter, and orbital insertion in April of 2030. So we'll do 2 gravity assist along the way. Launch. Oops, that thing didn't work here. That does not work. Anyway, gravity assist out at Mars in a couple of months, and then come back in 2 years and do a gravity assist by Earth. That's on here too. So go by Mars, go out a little bit further. So it's a 6-year trip to Jupiter, but if you watch the date, it's a little over 2 years before we do this set. So we're back at Earth in 2 years, and then 4 years to slingshot all the way out to Jupiter. Doesn't quite take 4 years on the animation though. But anyway, I want to leave this. So when they get ready to orbit or get ready to go into orbit, they're going to have to burn all 24 engines at full capacity for 6 hours to slow down enough for Jupiter to capture it. So that's a lot of energy. And then once it's captured, Nope, that didn't work. Anyway, so it'll come in, do a first pass, and then these are going to be large elliptical loops, and they'll adjust it over time and bring it in. So eventually, it will technically be in an orbit around Jupiter, going out in elliptical orbit, and then coming zipping by Europa every so often. So and it'll be passes for Europa. They'll be as low as 16 miles in some cases to get a good, so those instruments can get a good sample. So over time,
trying to move to the next slide?
Yeah,
You're hitting enter and it's not working?
yeah.
President airspeed.
I've got, right arrow.
Okay, Trevor, you're up. There's also those arrows at the bottom, right?
Yeah.
It's advancing over here, but it seems to be locked up on the.
In praise.
I have a question.
Yes, sir.
How long has the pre-mission planning?
In praise of mystery. Of hope.
One more time.
How long has this, Europa Clipper been in development and design, development, test?
I don't know when they actually made the proposal. Like I said, that concept was done in 2010, and then the decadal survey came out in 2013. So I'd have to look, but probably somewhere around 2015, I think, would probably be a good estimate for when it was approved and to go forward.
I have another question.
Okay.
So, how, I don't know to what extent this answer is possible, how you compare Titan with the Europa? Because at some time, I know some time ago, Titan, Saturn moon was also a candidate for life. So how do you compare?
Right. I think they've found indications of a lot of organic molecules, methanes, and that on Titan. I think that's probably one of the main reasons it was selected for the New Frontiers mission to go take a look at that. So.
Because I think water is not such a good, like, water is more found on Europa.
Right. And I think on Titan, they're finding like liquid methane. It's so cold that they're finding liquid methane in that type. So kind of a completely different environment, but you do have a lot of organics. And we never know.
Because of life also, like with methane, the life is different than in water, maybe it is water-based life, I mean.
Right. And they may be looking for like, building blocks of life with the organics on Titan. So, I'm not up on Titan very much. So, but yeah, different, all these different environments that we're finding out there. So. Close to there. Okay, yeah. See if we. All right, thank you, sir. All right, this one worked. Let's see if this one works this time. There we go. This is high speed, obviously. So, but you see, as each orbit. They're bringing it in closer and closer. And if you watch the pattern it's making as we go through, and then you can kind of imagine this is how we'll build up this map over time and get a full image of the entire surface.
So
Okay.
like a quasi-periapsal precession of the orbit,
Okay.
where it's actually orbiting, it's actually wobbling, almost wobbling around Jupiter, changing its closest distance to Europa. As
Yeah, so every one are offset a little bit.
Kind of like Mercury's orbit, so perceived sort of a perihelion, in this case a periapsal precession.
Okay, did anybody send your name to Europa? One? I did, this was, kind of a public engagement deal. They do these on a lot of the big missions, so you can sign up and they'll actually engrave your name on I think you could do a little message too on this one, if I remember right. Some of the other ones you do your name, some they'll. Anyway, so they engrave your name on a microchip, and then that gets put onto the spacecraft and goes to Europa. So they ended up with about 2.6 million participants. And so they call this message in a bottle. So now this vault plate down here, this is what so all the instruments on the spacecraft are in some sort of aluminum alloy vault. The walls are about a half-inch thick to protect the instruments from the extreme radiation at Jupiter. So this is kind of the outer vault plate. So this is kind of in the spirit of the golden record on Voyager. So they've got, the outer side, those waveforms you see, that is the word water in 104 different languages, and these are the waveforms that are engraved on there. So that'll face to the outside, and then to the inside here, we've got several things. We've got the Drake equation there at the top. And then if you look, there's I lost my pointer, but right there in the middle towards the top, that little image, kind of a representation of the Jupiter system with the bottle. The microchip is actually mounted right there in the middle where Jupiter would be. And then there's a engraving there of, oops,
In praise.
wasn't supposed to do that. Okay, this is the poem.
For Europa.
Can I go back? Okay, so this is forget where.
In praise.
Excuse me.
Okay, hold on, I got a question for you.
Yes, sir.
Before you move on. You got the hydroxyl and hydrogen radio waves, where are those on there? See in your first paragraph?
Uh-huh.
What is that?
Those are the
So next to him, his picture to the right.
It's right to the right where I heard.
To the right.
Oh, is that
it's right there.
supposed to be
Yeah.
Those sign-
Okay.
We keep going. Okay. All right, I'm gonna have to hold it. Okay.
Yeah, those
All
are
right.
wavelengths for hydrogen and OH for radio waves.
Well, it's one's 21 centimeters, one's 18 centimeters, I guess okay.
We'd have to zoom in.
Okay, I got it.
So,
I got it now.
okay. So, and then there in the handwriting, that is is the poem there at the top, In Praise of Mystery, which was written by Ada Limon, and that is her handwriting. So I'm gonna see if we have any more questions, and then the last slide is her reading the poem in her own voice. So no questions, I will let it advance. It's a very nice poem.
In praise of mystery, a poem for Europa. Arching under the night sky, inky with black expansiveness, we point to the planets we know. We pin quick wishes on stars. From Earth, We read the sky as if it is an unerring book of the universe, expert and evident. Still, there are mysteries below our sky. The whale song, the songbird singing its call in the bough of a wind-shaken tree. We are creatures of constant awe, curious at beauty, at leaf and blossom, at grief and pleasure, sun and shadow. And it is not darkness that unites us, not the cold distance of space, but the offering of water. Each drop of rain, each rivulet, each pulse, each vein. Oh, second moon, we too are made of water, of vast and beckoning seas. We too are made of wonders, of great and ordinary loves, of small invisible worlds, of a need to call out through the dark.
That's it.
Thank you, Leonard. Sir, great presentation.
Alrighty. Thank you, Trevor, for saving us there in the middle of all that. Let me get to the next thing. That's all the bonus stuff. Okay, where's Ron? You want to tell us a little bit about the DVD library?
We've got about 200 DVDs. The ones you see on the screen up there, the ones to the right, Infinite Cosmos, are actually from Astronomy Magazine. That's the bulk of them, probably 80% of them. And we also have the great courses, the ones you see on the left. We also have, for loan, and if you've been here a couple of times already, unbeknownst to you, you are a member. And we also have pocket atlases, which I understand from David, these are now out of print. Yeah. Into astronomy.
Collector's item.
Planisphere, moon maps, and if you don't have a DVD player anymore, we actually have a loan that, just plug it into your laptop. So if you need it. Thank you.
Great. So during the break, you guys can go up there and get a DVD from Ron and check it out and keep it for a little bit and take it home and watch it. All right. So if you were here last month, that young lady right there won a telescope is our telescope drawing. So we have some things that we're going to do drawings for. We have the door prize tickets, which David gave as you're coming in, but separate from that, we're going to have separate drawings for other items. The reason is because we only want people to, get these things that actually want them. So Chris and Angie donated a UHC filter, which is very nice of them to do that. And we're going to have a drawing for that. The tickets for that drawing will be over here at the end of this table during the break, right there. There'll be tickets down there. If you're interested in the UHC filter, come down and get yourself a ticket and you can be entered in the drawing for that. So UHC filter is a filter that you can use to kind of suppress light pollution. There's the plot there for it. It mostly passes the blue and the red and kind of blocks the yellow and green. 1 ticket per person, drawing at the end of the meeting. And it's a 1 1/4 inch filter, can be used both for visual observation, also can be used for astrophotography. So the manufactured claims is good for both. This is an example of what a UHC filter does. There's without the UHC filter and with the UHC filter. Yes, it turns things blue, so don't tell me, it turned things blue. That's what it does when it passes blue and red. So you can see the red and the blue are passing and everything's green and yellowish or suppressed. But they're really good for planetary nebula and emission nebula. So if you'd like to win that filter tonight in the drawing, come down and get yourself a ticket and you could be the winner of this UHC filter. After the meeting, we're going to get together at Mod Pizza. You just zip up Middlebrook, go west on Clear Lake City Boulevard, past El Dorado, right in front of HEB. There's a Mod Pizza. We'll get together and talk about astronomy and other topics. And everyone's welcome to attend. We always have a nice time right after the meeting. Come and eat pizza in the middle of the night and make yourself sick. All right. So we're going to take a short break, and then we will come back with the second half of our meeting. So see you in, we'll say, you guys like to talk a lot. So about 10 minutes, 15 minutes, and then we'll get going again. Thanks. All of you know it. You came to the right place. There you go. We're trying to improve our reputation here. That's the one of the UAC filter? That 1 minute until blast off.
You see that first one?
So I did that. But it also has a small sensor for the and then you gotta go through with the sky that we're getting. So I watched 3 YouTubes where they were evaluating the next game. And they said, you can't go 3 nanometers, you know, for that thing, you gotta go 6 nanometers. It's never, gotta go. Yeah, you won't get enough. So I ended up doing that, and he actually suggested, okay, 15 minutes is up. We're going to get started with the second half of our meeting. Thank you. All righty. Members' minutes, Cygnus at 30. So if you go outside at night right now, and as soon as it gets dark, a little while afterwards, look straight up, and one of the most prominent constellations you're going to see is constellation Cygnus. And when we were at Okie-Tex, there was 5 of us went to Okie-Tex. I thought it'd be fun to, instead of what I normally do, a telescope, I took a camera, a modified Canon camera, and a camera lens, and I was going to shoot some wide-angle shots to get entire constellations. So this is a picture of Cygnus from Okie-Tex. And so is there a problem? What? I'm not aware there's a problem. What's the issue? Apparently there's a problem that we cannot understand. Yes. The stream not working? Super delayed. Well, I don't care about that. Anyway, so when you go outside in our area, you see a few stars and you can make out the Cygnus. But when you go to Okie-Tex, you can see things like this. Not quite this good because it's a long exposure picture, but much better. And this is with the lines added, where you can see the constellations. Cygnus is the swan, also known as the Northern Cross. You can make out the cross, and hopefully you can make out a swan there if you got some imagination. And then this is some deep sky objects that you can see in this image. Over here, whoops. Okay, North American Nebula, NGC 7000. That's actually a narrowband image, where this one's RGB. You can see that up there. And down here, the Saturn Nebula, IC 1318, right there in the middle, sometimes called the Cygnus Nebula. And then over here, you can see the part of the Veil Nebula, NGC 6992 and 6995. So now this is the same image, but with the stars removed. So you can kind of see the structure of our galaxy. The Cygnus is right in the middle of the plane of our Milky Way galaxy. And so when you're looking at this, you're looking at part of our galaxy in the plane. And with the stars removed, you can see the DSOs and the dust and gas a little better without the stars there. And then one more thing. Okay, one more thing. I know that you guys have been greatly disappointed. But for the last couple of months, I have not said anything about radio astronomy. Look how happy you are now. You're all so happy. See, it's not target. So, radio astronomy related to Cygnus. This is a 2.1 meter radio telescope and with a 1667 megahertz cylindrical waveguide horn. And what I'm looking for is hydroxyl. So there's Leonard up there. And remember a minute ago, he showed you a chart, a thing that was on the Europa Clipper that showed the wavelength of hydrogen and the wavelength of hydroxyl, right? OH and H. And the reason that is because hydrogen was one of the first things, the 21 centimeter line was one of the first things they could discover with radio astronomy. And I believe the second thing, according to my book, was hydroxyl was the second thing that they were able to discover, the hydroxyl line. So as I've been showing you guys for years, I've been out measuring hydrogen and all that, and I've been determined that I would like to also measure hydroxyl. So I've been trying to do that for over a year. And so I'm going to show you the reason why we want to measure hydroxyl is because it's actually that hydroxyl is in molecular clouds. So the hydrogen is the neutral hydrogen that's in our galaxy that we can measure with a radio telescope, but the hydroxyl will show up when you're pointing at molecular clouds or dark nebula. So here's our view of Cygnus again. And this one's stretched a little bit more. And right here is, okay, first off, this blue line here is at declination about 35 degrees. If this was a good map, I would be able to have, the declination would be a curve, but I couldn't figure out how to make a curve in Photoshop. So it's two lines and those are at 35 degrees declination, roughly. So this middle one here, right here, this is Barnard 144, which is this dark nebula right in here. This is all hydroxyl. This is a hydroxyl measurement with the radio telescope I just showed you. And that's that dark nebula right there. And it's over here on the radio telescope plot. And then this flat area right in here, I could not find a designation for this. Hold on. I just called this 1 because I could not figure out what this one is. There's a dark area right there. And that's that flat area right here on the graph. Then this one is where you see 2 on the picture. And then this one is LDN 870, which is Lens Dark Nebula, which is a collection of dark nebular molecular clouds. And then 3 is over here. So either I'm just going crazy or we're actually measuring hydroxyl with the radio telescope, which is a good thing because it's a lot harder to do than the neutral hydrogen is. So hopefully that will satisfy your radio telescope desires that you've been having, and you'll all feel better now. Any questions about that?
I think it lines up this over more than one night.
That is just one night. Yeah, the radio telescope is just pointing in one direction, doesn't even move, and the sky's going by. And then that's the plot as the sky's going by.
So we didn't see it.
As what?
If it's repeatable the next day, or is this just?
Oh, you know what? He just said the most nasty word in the world, repeatable. Okay, Kerry. See, Kerry actually, he knows a lot about radio stuff that I don't know. So Kerry's our real expert. But I did this the night before we went to Okie-Tex. The night before we went to Okie-Tex, I got that plot. And I was so happy, and I haven't done it again yet. So Kerry, I may be full of baloney. I may be totally full of baloney. But it's awful big coincidence that.
I was going to say, if you rotate that 90 or
Right.
counterclockwise, it kind of lines up with how you got them on.
What are you talking about? It lines up perfectly with
Your
them.
graph of your data.
Yeah.
You turn it,
Oh, I could do that, but
it lines up with the.
you guys can do it. You can do it in your head. Anyway, but the point is, Kerry, this Barnard 144 is exactly down to the minute when that thing transits. So it's like it was at 9:02, and that's exactly when that was, 9:02, perfectly. And each one of these hits it right on the button. You know, LDN 870 is right at the moment that it was transiting. So it'd be an awful big coincidence that I had 5 things in a row. Yeah, it may be. It's an incredible coincidence. I got 5 in a row of dark nebula that transited right when the signal occurred. But you're right. I will repeat this and try to get it better. And the other thing I'm going to do too, Kerry, is this thing over here, that is way darker, right? That's billions of times darker than this little thing here I was measuring. So I'm going to go for this one. I'm going to try to get that one instead. That is way bigger than any of these other ones. I'll let you know. Stay posted. All right. Any other questions about this feat of achievement here? Right there.
Any particular polarization that you're looking at?
Yeah, that radio telescope actually is polarized. If you look at the way the circular waveguide horn is, But most things that I measure are non-polarized. I mean, stuff from space, the majority of it is randomly polarized. It's all over the place. Yeah. There are things that are polarized, like synchrotron radiation, like from a pulsar, is polarized. Yes. But I'm not that sophisticated to do that. Any other comments, questions?
I am interested.
Oh, there she is. What?
I don't know anything about radio astronomy.
Well, you do today.
I don't know, I don't have information, it may be a dumb question. But one thing I'm thinking that when you get results from radio astronomy, radio observation, then do you think that it has something to do with the densities also?
Yes. Yeah. The denser it's going to be,
That's what I-
exactly right. Same thing with the hydrogen,
Yeah.
Yeah, you absolutely, like when I was doing the hydrogen measurements, the densest areas were huge and the lower density. You actually see hydrogen almost everywhere you point your telescope, almost everywhere. But when the Milky Way goes across, definitely the densities change.
If there is matter, there should be hydrogen, I guess, almost.
Everywhere. There's hydrogen everywhere you point it. And so any of you guys trying to do radio astronomy, you will not have any trouble, measuring hydrogen. It's everywhere.
But hydroxyl is something, this is something which depends a lot on the chemical composition and all type of reactions and energies and temperature, and I don't know, a lot of stuff.
Right.
So that's more like a lot of multi-particle phenomena is there.
Right. It's not everywhere.
Yeah, it's very special conditions, and I'm really kind of thinking that should we really expect it in nebulas?
Yes. Yes.
That's something like,
Absolutely. Molecular clouds, hydroxyls and molecular clouds. You should talk to someone who teaches astronomy, so they could tell you all about that. Yeah, hydroxyl, molecular clouds, or the signature of molecular clouds is hydroxyl, the strongest.
You know what is my reservation? My reservation is that when we look at these things, we are observing everything from the distance. So the depth of space, we all know that. So due to that reason, I'm not really sure that the density which we are thinking is really the density there. That makes sense?
Yeah, it's optical depth.
Yes, optical depth.
The optical depth, that's correct. But okay, let's look at this. Okay, down here, let's look at Barnard 144. Now you can see that you got this gigantic gob of stars and dust and everything else. And you can see there's a dark region right in the middle of that, right? Can you see that? Yeah, so there is stuff there that makes that dark nebula. I mean, that's dust and gas that's blocking the light from all of the stars that are behind it. The only reason that's dark, that's not a hole in space. That's a dark, dark nebula.
No, I have no problem in that. This I understand. But the reason that I'm talking about it, and I am not saying that in the clouds, hydroxyl cannot be there. There is definitely a possibility. But when you look at the stellar composition, and if you go to chemistry, the concentration is very low. It's not impossible to find it.
Right.
But even if it is there, the concentration should be very low.
It is very low.
So due to low concentration, the probability of detection is reduced. That's why I'm kind of.
That's true, but in the radio astronomy world, the first thing they detected was the neutral hydrogen. And the second thing that was detected was hydroxyl because in these molecular clouds.
In that sense,
It's the second strongest signal that you can detect.
Okay, in that sense, I can understand because you cannot go to larger molecules or larger things, but small. Oxygen is of course there anyway, so hydroxyl is a possibility.
Well, I mean, you can look it up, but yeah, the definition of a molecular cloud, there's like this list of molecules that are in molecular clouds. Yeah, and the most prevalent one is hydroxyl.
No, I am not against finding that it cannot be found. I'm just like the detection and the composition. That is what I'm trying to understand. That in the composition, it has enough concentration that it can be detected.
Yeah.
That's my concern.
Well, it's a common thing that's done in radio astronomy. Yeah. Hydroxyl is how they measure molecular clouds. Yeah. So it's just normal. I haven't seen any amateurs do it, but I'm sure other amateurs are doing it. I'm just not aware of it yet. Okay. Any other comments or questions on hydroxyl? All right, moving on. Okay, second one, asteroid Ganymede. Now, another thing, we were talking about Ganymede a little bit ago. Ganymede, which is an asteroid, is not the same thing as Ganymede, which is a moon of Jupiter that Leonard showed you a little bit ago. These are two different things. But right now, Ganymede, which is the largest known near-Earth object, is actually fairly bright and close by. So this thing is about 35 kilometers in diameter, orbital period 4.34 years, rotation at 10.3 hours. And this gives you an example. I guess you can't see it very well, but anyway, it shows the orbit of Ganymede around a solar system there. I know some of Leonard's slides is hard to see some of these. Okay, this is a curve that shows the closeness, how close it is to the Earth. And right now, right here we are in 2024, around this time. It's actually the closest it's going to be for a long time. And this is a light curve that shows how bright Ganymede is. And the brightest it's going to be is around October 18th. And it's going to be 8.79 magnitude. So it's definitely bright enough that you can see it. This is a video that I made a couple nights ago, on the night, 2 nights ago, of this asteroid. This is 3 hours compressed into 3 seconds. So, and if you can see the star field around it, this thing is plenty bright. If you can see those stars around it, you can definitely see this super bright asteroid that's moving along here. It was in Pegasus when I did this video, but it's moving along pretty quick, so who knows where it is now. So just want to make you aware of that asteroid Ganymede is up, it's bright. You want to get out and see it? There you go. Any questions about asteroid Ganymede? Near-Earth object, the biggest of all the near-Earth objects. 35 kilometers. Hope it doesn't land on your house.
This is a good job, man.
Oh, you love it? Thank you. Thank you. All right, cool. All right, next up, we got Dan's going to tell us about the North Houston Space Society.
Yeah, I was space cadet. Well, as you can hear, I was not born here, but I fell in love with the United States in the 60s. At a time when it was difficult to fall in love with the United States in France. But I proudly fell in love and continue to do what I could to help. Met some people at the American Embassy, and little by little, I got invited, and here I am. I worked at Goddard Space Flight Center on Landsat. Then the DOD noticed me and shipped me to Pittsburgh, PA, for heaven's sake. That's why I talk like that, okay? And in Pittsburgh, I worked in software. And I still love the space program. I'm too dumb to change my mind. I fell in love with NASA. I still love NASA. And I will keep working the best I can to share what I know about the space program with kids in particular, because at the winter of my life, I want to help those that are at the spring of life see the joy of science. And in particular, every first Saturday of the month, Lake City trusts me with a little corner of the park in Rustic Oaks Park on the first Saturday of the month. From 6 to 7, my wife and I and some partners, a good friend from the Navy, former nurse and microbiologist, we show microscopy. We have prepared slides. We show whatever is floating in the nearby stream. And from 7 to 9, we have telescopes. And we show the kids what we can. Now, I happened to find a wonderful group with the National Space Society. I've been a member for a while. But I was unfortunate to select the South Texas group of NSS. And it is not a very active group. And for a number of years, I was not happy. And then, poof, I was at Rice University, and I met a wonderful French guy who was actually a flight director at Kourou in French Guiana when the Europeans launched their spacecraft. And we became immediate friends, and he was also part of this group. So we're going to have a barbecue at my place tomorrow. And it is a very exciting group, very active. I would urge you to check them out. They meet on the second Saturday of the month at 2 p.m. You bet I'll be there. For me, it's a big trip. I mean, it's an hour and 10 minutes, but it's worth it. You can come in person at the Barbara Bush Library, but there is also a Zoom link. And we have a wonderful speaker tomorrow, actually, Michael Flores, who has being a public affairs specialist at JSC, is a Hispanic, and also engaged in medical research, another guy I'm looking forward to meeting. And unfortunately, he works for Chevron, nobody's perfect, okay, but he tries to educate the lawyers at Chevron, good luck, about advanced technologies. But I think that's a very good thing to do. The more you know about technology, the better the entire planet is. This is the guy. So anyway, I want you to know that there is an active chapter of the National Space Society. And these guys are doing a wonderful job, in particular lobbying Congress. So it's a wonderful thing to know that I love NASA, but NASA is in this day and time the only kind of bi-party, totally unbiased support that we get from both sides of the aisle. So it's wonderful to be part of that. That's it.
Okay, so David's going to tell us about Fort McCavett. We have some people who are going to Fort McCavett who have never gone before. It's 2 weeks from yesterday that we're heading out to Fort McCavett to do some astronomy. And I asked David to tell us a little bit about it for those people who haven't gone before so they know how it works. Here's David.
Well, as we've discussed, Doug, we probably should have done this last month, but that's the way it is. All right. What do I do for advanced? Enter?
Enter, yeah.
All right. Fort McCavett, October 24th and 27th, 2024. There's longitude, latitude. On the short side, here we are here in Houston. Well, technically it's Pearland, but okay, we're kind of down here off to the edge here. I think it was the 365 from driveway to driveway coming down I-10, San Antonio. You come up to about here and you make a right turn. This is literally a marathon's distance, 26 miles from I-10 up here to the fort. It also depends how many, how fast the crows fly and how many stops you make along the way. The scenic route is actually up over through here. But if you want to take, that'll probably add a good 2 or 3 hours, depending on if you're antiquing and doing those kind of things. Up past Junction, past Kerrville. Junction's up here. Junction's about your last major town you're going to get to until you get to Fort Stockton. So if you hit Fort Stockton, you've clearly gone too far. Make that right turn right up here. Come all the way up 23 miles. You'll come all the way up here. Now the fort is sitting right here. You come up to a T. It's about Railroad Road. And you come around the corner here, and then you come in here on the side. Now, I'm going to show you some dated slides. RVs are welcome. You do need to get with Lisa Lester on that beforehand. RVs are only accommodated up here. In times past, we used to have them back here with pedestals. That's not allowed anymore, but you can have RVs up in this area. I think they've got room for 3.
I got a question.
Yeah.
So she's saying barracks 3 for the tents. Which do you know which one barracks 3 is?
I always thought it was for tents.
Yeah, she's saying put the tents by barracks 3.
News to me. I always thought they were back here, but I had to stay out of.
Maybe those are those barracks ruins?
Yeah, these are the ruins. We would often camp. Connie and I would often camp in there and use the old ruins as windbreak.
So which one is 3? Nobody knows?
Not off the top of my head. Chris, you know which one? Is?
Which one is barracks 3?
Yeah.
All that is 3? Okay, the whole line.
Yeah.
All right.
You can't miss it.
Well, I know where it is, but I thought maybe like 1, 2, and 3 or something. Okay.
There we go, a little bit more. Center flagpole, the main parade grounds, barracks. This is where I see most of the people staying. I'm assuming that's where they've been staying all this time. There are cots in there. You have to accommodate your fellow astronomers that might snore, so got to be nice. All right, parade grounds. I think that tree is gone, right? Yeah, the old hanging tree. This is the barracks that were there on the ground before. A lot of people park their way out in front, have a little bit of fun there. These are the old barracks that we're seeing from the air that we used to use as windbreaks for tents. People with the scopes out. More scopes out. I don't know if one of these is Chris's or not. That's a dated one of us. Glenn Schaefer and then a few others out there. That might even be our trailer. I don't know.
That barracks that's actually built,
Yeah.
when they're staying in there, is the rules still stand that they have to pack everything up during the day?
I think they have to make it neat so that so that it can be, the barrack can be shown in its historical context. Parking is usually in back, if I understand correctly. Now, this is one dated slide that it can't be held anymore. But beforehand, when it was under Texas Parks and Wildlife, we would have a line of pedestals out there for RVs. But that's up at the main grounds. Friday night is usually a potluck cookout. We go for that. If you see, I just dropped his name, Fred Miller. Stay close to him because he's always cooking something, and it's usually always pretty good. I always gather around for the group shot. Again, here are those ruins here from a little bit, see it a little bit better. No, I need to strike that. There is no barbecue on Saturday. You're basically on your own for all the meals now. So what to bring? Doublecheckweather.com or your favorite weather app. In March, we've had weathers in the 70s and 80s all the way down to 21. Check the weather at least 10 days prior and watch it through that time. Pack accordingly. Do not bring a fleece sleeping bag if it's going to be 30 degrees. That would not be a wise decision. Scout motto, be prepared. Come with Google Maps of the area just so you know, so you can get to Menard, which is 20 some odd miles away. Junction is about 60, but Junction's got a little bit more. If you really have that fix for a Walmart, you can go to San Angelo at 90 miles away, but understand you are getting further and further out. Plan ahead, plan all your own meals just in case. Friday night, bring something to grill as a side dish. This is a potluck meal. Thursday, if people arrive early, there's usually a group headed to Menard. I'm assuming those restaurants are still there. Some of them only take cash. You pull out a card, you're going to be washing dishes. Ice for coolers, you've got two options, Menard or Junction. Usually word will get around if somebody's making a trip. See if somebody will spot you a bag of ice and go from there. Plan what you want to eat and how to work it. If you don't have a camp stove, bring a folding table, electric skillet. You can usually get power out there as well. Don't forget the coffee pot. Do bring plenty of bottled water. It is 2,200 feet up and it does tend to get dry. So arrive on Thursday, dinner's on your own. Friday, breakfast and lunch is going to be on your own. Dinner is usually a communal potluck of whatever people are bringing. Saturday is breakfast and lunch. Dinner's on your own. I think we got it working where we can stay till Monday, so you can actually set up and bring a dinner for Sunday night. Absolutely make sure you're in contact with Lisa Lester. She's the one who coordinates all our things, all of our efforts while we're there. Showers, they're two open aired, but they are enclosed. At one time, this club did pass the envelope and we built those outdoor showers. But you can look up and see the Milky Way while you're taking your shower. Only buzzards and airplanes with really good cameras can see you. So bathrooms those are regular bathrooms. They do have fairly comfortable porta potties. I know porta potties have a bad reputation. They keep them clean for historical purposes. Great skies, weather permitting, and it's a chance to get away from it all. Don't plan on much in the way of service. Last I was there, AT&T is passable, but Verizon goes DOA, much about a couple miles above I-10. Need to be self-sufficient. All about you're going to find in Fort McCavitt is the sky. That's why the club was going there back when Hernan got it set up in the mid 90s. Nearest town is 20 miles away, as I mentioned. Junction's about 40. San Angelo is a good 80 away. So if you get the feeling you're out there in the middle of nowhere, that's because you're out there for the stars. So don't expect a lot of network unless you bring it yourself or you're bringing your own Starlink, et cetera, et cetera. Feel free to ask the email group on the club for any questions, but all reservations and everything else has got to be handled through Lisa. Any questions? Again, we probably should have done this a month ago because Doug and I started catching wind of people being interested in going, which is good.
Did you say camp stoves were not allowed?
No, if you don't have a camp stove, bring an electric skillet because you can tie into electricity. I think according to Lisa's last note, there is no burn ban, so you should be good. Should be good with a camp stove. All right, gonna make a fast slide into the star party. We had a fairly busy September. One hack, the LPI, I did not get any information on this or how it went. Okie-Tex, I've got a few, Doug provided me a few slides from you guys that went, and then we had to turn around, we had another hack. Next up, tomorrow night, observe the moon night at the George. Both Leonard and I are talking, different points in the afternoon, of course. I'm assuming they've got the scope set up for it. 24th through 28th is club's trip to the fort. 28th of November 2nd is El Dorado. We're now trying to set these up leapfrog, so you can go to one, pack up, and then hop and go to the other. El Dorado is about 50 miles to the west of the fort, and it makes for really good observing. Slide out to November 1st, which will be our last hack event of the year. November 9th, Saturday, we're going to be at Evelyn Meadow. They will definitely wanted us back. November 12th, UH Clear Lake here. I think that's with you. November 14th, I got talked into coming out for an event at Armand Bayou. Moon will be up, but hopefully that's all it's going to be because Armand Bayou, the lighting there is a little bit iffy.
Where is this 14 number?
Armand Bayou Nature Center. It's further out on
I mean, near the entrance or location is that?
within the park. I'm gonna have to get that information from them. But other than that, they have a group. They're meeting, and then they're coming out, and then they're coming out of their meeting hall around 7:30. We got to get the details worked out on where to be. So they will let us know.
And for consequence, you might want to tell that it is going to be right next to this building loading down, within the same.
This one on the 12th, yeah, where it was before that last time,
Yes,
yeah.
Because if anybody wants to come, they know where it is going to.
Doug,
So, yeah, I got a question for you. Can they turn off those lights by the dumpster?
Yeah.
Okay.
Like that's the loading dock for this building.
Are you doing loading dock, or are you doing out in the middle?
No, the one where we have all the time. The
it's
same
out
day.
there at the loading dock.
You're doing loading dock, right?
Loading docks.
And you're going to be able to turn off the lights in the dumpster area.
Mm-hmm. I think you will have to bring your, we block it with the vehicles.
It caught on fire last time. I put a tarp over the lights and they caught on fire.
That's why I was asking. In fact, I talked to Brandon and I was asking that what is the better, because I can use any place on campus. The only thing is we have to see where we can.
Okay, we'll suffer. Okay. So David, the Armand Bayou thing, now, is this a normal star party or is this something different than that?
It's a normal star party that they've asked for.
Because originally they were asking us to teach them how to do a star party.
It's-
Remember that?
It's changed.
It's changed. Okay.
Yeah.
So it's a normal star party. Okay, good.
I'm sorry, I can't help my little personal bias. They keep changing whatever it is, the goalpost. It's finding that bar of soap in the bottom of the bathtub. I can't get them to tangibly get a hold of what exactly they're looking for. So last conversation, it's a star party.
Okay. That's what I didn't understand, so good.
Well, I'm right there with you. All right. And then November 6th, actually not tentative, this got confirmed. Magnolia Creek Golf Course asked us to come out. Hopefully we'll be seeing something there, and they will provide some level of sustenance. All right. 14th, Saturday. Special thanks to Chris Randall, Bob and Leslie Eaton, Reed Klotzer. We had up about 150 in attendance. We were kind of mucking with a little bit of the clouds here. Seemed to be working out okay. Reed was showcasing his sea star and getting some very good images off of it. We were able to show a little bit of the moon, little other things, but he was able to dig out 57 and 27 with that thing. Chris getting his scope set up over here. There's Reed. You can almost kind of see a little bit of a haze in there. Sorry, but that's kind of the way it works sometimes. All right, October 4th was literally a week ago. The Hack Winery, special thanks to Martin Heidi Junko. Just me and them, and fortunately, we only had about 75 in attendance. Look at the horizons. Boom. Out here. And then this is actually with the night vision camera of the, that's not the right term. What's that called, Connie? The night scope, when you tell the camera to take a long night mode. It's actually pretty freaking dark, but I wanted to highlight Saturn. That was the showstopper and just about the only thing we could see that night. The moon was way off in the western sky. Took a chance that we could actually get some deep sky stuff done. But these clouds were pretty much banjacking us through most of the night. And they've also cut the hours back, which is actually quite good. It's only now 6 to 9 instead of 6 to 10. All right, may need a little coaxing here, but I got these pictures from Reed, Stam, and Doug, Okie-Tex, out there. I love it in the middle of nowhere. I was curious about this one. What's on the other side? What's on the other two sides?
That's called the Four Corners marker, I guess. Anyway, so there's 2 Oklahomas, and there's 1 Colorado and 1 New Mexico.
Huh.
So it's right there at that corner. That's where these states all come together.
Okay, cool.
And there we were out there. There's actually 5 of us. So there's 1 person taking the picture. The Okie-Tex 5.
Al and Brandon. That's a monster, Al.
He's got a bigger one than that. That's a small one.
That's a small one.
He's got a 25-inch sitting right next to him. He's really serious.
All right, and then Stam, and then Reed, and then it looks like you got some good power there too, Reed. And then, where did that come from?
Oh, we found that bone ourselves.
Of course you did. Of course you did.
For everyone else to enjoy.
Uh-huh.
That's right across. You know what? This thing is really near Okie-Tex. Every time I've gone there, I always said, "Oh, it's right there by the road," you know. And I've never seen it, so we finally found this thing. And we all went out to it. You can drive actually real close to it. It's not a real bone. That's a piece of cement.
Facsimile bone, one of those.
Yes.
Okay.
Yes.
All right. And images were, of course, taken 27, and assuming that's what.
I think that's JSC 253.
Let's see. I like the arm structures you've got on this one. Really good. All right. Any questions? I found a butte this time. When I die, I'm taking you with me. All right. Thank you.
Okay, so as you can see, we got lots of stuff going on this fall and lots of star parties and many things. Okay, so next month, we're going to get together on November 8th, right here, thanks to Dr. Masood. Jonathan Kistner, Red Scope, Blue Scope, 3D printing and amateur astronomy. I saw this guy give this talk at Okie-Tex. It's really cool. He has made a whole bunch of telescopes and he 3D printed all the parts of these things and put them together. You can go online and get these things and print them and actually make your own telescopes, 3D print the parts. And it's really a great presentation. It's not just simple telescopes. He's got ones that got, motor drives and all kinds of stuff, go-to. He's really sophisticated in the things he's done. Okay, the filter drawing. Did anyone not get a filter drawing ticket? Anyone other than Andrew? Okay, anyone other than Andrew do not get a filter drawing ticket that wants a filter. If you're holding your hand, I can't see you. Do you want it? You want it? All right, get down here then. I'm not gonna walk up there. Come on. Do you want the filter? Do you have a telescope? Is that a yes or a no? You don't need the filter. Okay, anybody that has a telescope wants this filter. Okay, fine. Hey, listen, we got a lot of other cool door prizes, okay? You got a door prize ticket, right?
Yeah.
Okay, you guys have door prize tickets. Okay, hold on. We want a door prize. All right, so I'm really glad the filter's in here. Okay, so I'm going to draw, and who's got the door prize bucket? Does anybody know where it is? Anybody be willing to bring that down here so I don't have to go get it? Okay, I'm shaking these up for this UHC filter. UHC stands for ultra high contrast. Somebody asked me that. Ultra high contrast filter. I'm not looking. I don't know what your numbers are. I'm not looking. I got one right here. Okay, the number is TU5. TU5. Who is TU5? Is it you? Is it really you? Are you serious? Yes or no?
Yes, I'm serious.
Get over here then. Come on, we don't have to laugh about it. Come get your filter. All right, Andrew. There you go. UHC filter. You know what a UHC filter is, right? Yeah. You'll figure it out. Andrew actually owns a video production company, and he actually makes a living doing this, so he knows a lot about this thing. All right, next thing is our door prizes. Okay, door prizes. Oh, now, did anybody not get a door prize ticket that wants one? I know the Grafton said we won so many door prizes we don't want anymore, so that's okay. You know, I gotta get, this thing is so heavy. I took an Advil before I came tonight because this thing is so ridiculously heavy now. I gotta get rid of these things. Anybody not get a door prize ticket? All right. What?
You dropped one on the floor
Where?
between the podium and the table.
Thank you.
That's personal.
Thanks, guys. Appreciate that. If you watch me for very long, you'll notice I make lots of mistakes. Okay, everybody got your door prize tickets? All right, first one is 695. All right, Leslie, come on down here. Oh my, Leslie, I got some things for you. Leslie, I have a James Webb Space Telescope calendar. I have a 2024 Night Sky Almanac. I have a book on the origin of time. You want to figure out about time? I also have a extra large T-shirt, probably too big for you, I think.
Yeah.
Yeah, you don't need that.
Yeah.
And I have some Spock socks.
I'll take that.
You want that one? That's right up your
That
alley.
sounds decent.
All right, good. Thank you, Leslie.
I would have loved to have had that filter though.
Oh, I know. Man, I'll tell you what. Well, yeah, we've been having some really good giveaways. I mean, last month we gave away a telescope. All righty. 669. 669. Who's that? David? Is he moving? Is that you? Yes?
Yes.
David, all right, come on. I know I got the perfect one for David. Moon map. All right, David, I have a moon map here. David actually makes these moon maps for us. So that's fun. Okay. Okay, I got a James Webb Space Telescope calendar. I got a book on the origin of time. I got Spock socks. I got a T-shirt. It's extra large. No, all right. And a book about as above, so below. Skywalk. Got socks? All right. Go, David. All right, very good. Okay, next one is, I'm not gonna read that one. Okay, I gotta do it anyway. 666. I hate to say it. That's the number. Does somebody have the devil's number here? I'm sorry if you guys got 666. Okay, no one wants to admit that they got 666.
Oh, we got one.
Really? Max?
Yeah.
All right, come on, man. Max got 666. All right, sorry, Max. Okay, sorry to give you trouble about that. We got a moon map. I got these books on the origin of time. One about Skylord. You want the origin of time? That's right up your alley, Max. Very good. All right. One more door prize. Oh. Got a plug for Max. Okay, last one for tonight. Okay, 698. Man, the Havlins are doing good. Come on down here.
I can't go down.
So Connie, you tell me from there, would you like this James Webb Space Telescope calendar?
What year is it?
2024? You wonder what I'm trying to get rid of? It's got pictures of James Webb stuff. Okay, I got a book, As Above, So Below Skylord. I've got, I got STS-93 crew pictures from Rick.
I'll let James.
I've got a book, White Holes. I don't know what that is.
I didn't sound.
You guys, come on, man, pick something. Okay, I got some socks, some Starry Night socks.
Oh, sure, I want them. Yeah.
Oh, you guys got both the socks then. Okay, very good. All right, everybody likes the socks. All right, very good. That's the end of our meeting. See you at Mod Pizza. Thanks for coming. See you later. Okay.
On this, and it was like pulsating on the top.
Yeah, in the middle. Yeah, we got it fixed.